Good morning. This video is for your science class for Wednesday, May 6th. Have your science calendar out so you can see where we are, and we're going to mark things off. So Monday you were working on your planet project, which should be complete. Tuesday we planted our seeds. If you weren't on our Zoom meeting, there's a video that will help you. And there's a great video on graphing and charts on Brainpark that is optional. It'll help you with 2 of our projects over the next couple of weeks. On Wednesday, so all of your science is going to follow the same format for the next 2 days. There's a Brainpop video. There's some extra videos and games posted in there. Then there's either an article from Newsela or ReadWorks. You can either read with me, read on your own, or you can go online. And then there's an ERQ question, and this is like your exit ticket. So the videos are all less than 5 minutes. Most of them are just a couple of minutes, but you do need to watch the videos to be able to answer your ERQs. And this is where I'm getting your points from. So 10 points for each day. And this will be how I'm assessing that you are reading and comprehending the information. And this is using your ELA standards. So these, if you can take a picture and send them via Dojo or email, or you can also do a Google document and post them and share them online. All right, so we're going to open up. All your articles are in your packet this time. So I'm just flipping through. We already got your plant data set up and ready, and your plants should be getting ready to grow. All the articles are only a couple of pages, but definitely some of these are challenge articles. So we're going to use all of our pre-reading strategies like we normally do. So if you're reading this independently, please make sure you use all the strategies, determine genre, look at your text features, and then look at our essential questions. So this one's really hard to see. We're going to actually go and look at it online because it is a lot easier to see online. Here we go. So our first one, we have our title, Classifying the Stars. Classifying just means put them in a category, from dwarfs to supergiants. And then we have a picture of a star throughout its life, as if you could see it across time. This is the life cycle of a sun-like star. Starting at the lower left, the star expands more and more until it explodes to form a nebula. All right. It's a Starlight, Star Bright, a subtitle. Every star changes over time. And there's this really great diagram. And this is really summarizing all the learning. We have 2 different scales. We have the luminosity scale. This is how bright it is. To illuminate means brightness. And you can see the sun is right here, pretty low on this scale. And then down here we have surface temperature, the heat of the sun. And we're going from cold to, we're going from very, very hot to less hot. Now you can notice, of course, it's the sun. They're all extremely hot, but this is all compared to the sun. So we have supergiants up here. And we have white dwarfs down here. Notice that the stars are also different sizes. All right, it says these are well-known stars in the Milky Way. Let's see if there's any on here that we know. All right, we keep going. It says main sequence. It says supergiants and white dwarfs. So here is the sun as a red giant. Look how big it would be. And this is how small a sun, so this is the dot down here. Oh, we lost our Newsela. There we go. So see how small our sun is compared to other suns. So part of how we see our stars is how close they are to us. So it could be a really, really bright star and it appears a really, really big star. It doesn't appear so bright because maybe it's really, really far away. Or it could be really, really close, and it may not be such a bright star like our sun, but because it's so close, it appears really bright. supergiants and white dwarfs. And that is it. So we're going to go back to our article and make sure you have your highlighter out and ready and your pen. Our essential question is, how do stars change and how are they classified? All right, so we have our title. What genre are we looking at today? Nonfiction or fiction? Nonfiction. And the type of nonfiction is called either informational, or some people call it expository. So it is not an autobiography, a story you write about yourself. It's not a biography, a story someone else writes about you. It is giving us information. All right, and this was in the photo. And I have a subtitle. And I have a diagram. Now, the information in this one is pretty complex, so I'm going to be helping you with your highlighting. The subtitle, I want to make sure we're really pulling out the key information. Caption and diagram. All right. You can either pause here and read it on your own, or you can close, read it with me. Oh, let's see before we read. There's definitely going to be some difficult words in here, so we're going to break them into chunks and get ready to read. Classifying. Classification. This word is scheme. That H doesn't make an H sound. All right, all these look pretty good. Down at the very, very bottom is a great word. Luminosities. Luminosities. Brightness. Just going through, making sure I don't have any words that are going to trip me up. All these look pretty good. Those are our two main words, it looks like. All right. Oh, don't forget it goes a little bit over here. This is probably your longest article. All right. There are many different types of, but all stars burn different to release heat, and scientists try to organize stars into according to their brightness, their size, and their age. All right. I think we have a couple of really important parts there. So what do stars burn? Gases. And what do the gases do? What's the effect of burning gas? Well, they release heat and light. And then this, I'm going to circle it because this is going to be our main idea. This was, notice our essential question too. Main idea. That we can organize stars into categories, and it's based on their temperature, their brightness, their size, and their age. That's what this article is going to talk about. All right, let's keep going. The main way of classifying stars is known as the Harvard Spectral Classification Scheme. It stars into different, based on how hot they are. Stars that fall between certain are given a specific letter. Every letter group is then further divided into smaller. These subgroups are numbered from 1 to 10. For example, our sun has a temperature of about Kelvin. The unit of measures how fast the tiny particles in each star move. The temperature means that the sun is called a G2 star. All right, so what's our first classification system and what do they classify on? So it's the Harvard Spectral Classification, and it's based on how hot they are, temperature. That was one side of that diagram. All right, starlight, star bright. Harvard Spectral Classification cannot fully describe A, however, it doesn't say anything about the star's brightness. This is important because two stars with the same temperature can have a very different luminosity or levels of. For this reason, the Morgan-Keeman luminosity class it uses Roman numerals like 1, 2, and 3 instead of Arabic numbers like 1, 2, and 3. The MK class uses Roman between 1 and 6. Each represents a different level of, for example, the number 1 is used for the largest and brightest stars, which are known as class 1 stars are further divided into 3 smaller groups. There's AI, O, AI, and IB. Dwarf stars are much smaller, and the supergiants or red giants, they're represented by the number 5. White dwarfs are a special case, though. They're represented by the letter D. Subdwarf stars are given the Roman numeral 6. To completely describe a star, the MK luminosity class is added to the Harvard classification. For example, our sun is a G2 dwarf, therefore its full is G2V. All right, now I think the main thing here is what's the second classification system. This one. You don't need to know these names, you just need to know that there's different ways to classify stars. And what do they base their decision on? The first one is temperature, and this one is brightness. And the next key in this part is they define the different names of stars. That's really important. You don't need to know which one uses Roman numerals or which one's created by this person, but you do need to know how stars are classified. So we're going to look at dwarf stars. Oh, missed the first one. Largest and brightest, supergiants. Dwarfs, smaller. Their name makes sense, right? Like the seven, Snow White and the Seven Dwarfs. Smaller and dimmer. And then white dwarfs. I don't think we need that they're the letter for them. All right, looks good. Every star changes over time. The Hertzsprung-Russell diagram is one of the most important tools to study. It helps figure out how old a star is and what is happening inside of it. The HR diagram plots the temperature of stars against their luminosity on a graph. Every star goes through specific stages as it changes over time. We're going to pause here, so I'm going to go ahead and give you kind of the main ideas. So one thing is that this chart helps scientists figure out how old a star is, and also that all stars go through changes. Did you know there's a life cycle of a star? And if scientists know how big it is and how hot it is and how bright it is, they can figure out how old the star is. Which is kind of like, have you ever heard when you cut a tree and they count the rings inside to see how old it was? This is kind of the same process, but with stars.